How can 0.3 turn into 30 and nearly kill you? In 2015, two sports science students in the UK took part in a caffeine test. The dose was meant to be 0.3 grams. A decimal slipped, and what got mixed was closer to 30 grams, which is about 300 cups of coffee. Both ended up in intensive care, and the university was later fined £400,000. Multiplying by 0.3 should make a number smaller. 0.3 grams equals 300 milligrams, which is realistic. 30 grams equals 30,000 milligrams, which is absurd. Rule: if your factor is less than 1, the result should shrink. This video is about that habit, estimation. Estimation is not guesswork, it's a quick sense check that catches errors before they snowball. It builds the number sense students need from primary through secondary. Everyone makes avoidable errors. High attainers are actually more tricked up by complexity, which leads them to forget common sense and the basics. So what is estimation? Estimation is a fast way to decide if an answer is sensible. We're just going to start with 5 quick questions that will help you in your estimating journey. Should the result be bigger or smaller? About how big should it be? Nearest 1, 10, 100? Do the units make sense? Milligrams versus grams, milliliters versus litres, minutes versus hours. Can I check to see I'm in the right ballpark, and does it fit the real world? Note that this isn't always available. Some exam questions are abstract, but a lot of GCSE and A-level questions usually try to be realistic enough for a sense check. So why does number sense matter? Number sense is an internal feel for size, built over time. Students with a strong number sense know that times in by 0.3 shrinks, and times in by 1.2 makes something bigger. They use benchmarks such as a half, 1, 10 and 100, and they catch nonsense. For instance, 4.5 times 1.2 can't be 54. This makes fractions, percentages, algebra and avoiding calculator traps easier. For Key Stage 1, learners are still building basics. That's why they need concrete materials first, like blocks, Q-snare rods or counters, before moving on to pictorial and then abstract questions. So what should you do if your learner struggles with dyscalculia and related difficulties? Certain students struggle with number sense owing to differences in the brain. These students are often diagnosed as having dyscalculia. Scientists believe that the intraparietal sulcus, a groove in the parietal lobe, supports our quick sense of how much. I'll give you an example of the type of problem that someone with dyscalculia might find tricky. For instance, if I show you a square filled with red dots, you can probably judge the amount at a glance. Now compare 2 boxes. Most people will say which is larger without counting. Students with dyscalculia may find this comparison slower or less reliable, and mapping the symbol, for example 15, to the quantity can be especially hard. It's just one piece of the system, but regular practice, quick, larger, smaller comparisons, placing numbers on a number line, and linking symbols to amounts appears to sharpen its contribution over time. So we're just going to go through some exam-style examples in both primary and secondary school education where you can use estimation. So if you have £2.49 plus £1.79 plus £3.10 plus 99p, we know that that equals £8.40. Now, if your total shows £84, a decimal has slipped. If you were to take a few seconds to round each of these amounts to the nearest pound, it will be clear that the amount is below 10 and not close to 100. So for instance, if you take £2.49, then you can round it to £2. If you take £1.79, you can round that to £2. If you take £3.10, you can round that to £3. And if you take 99 pence, you can round it to £1. That's £8 altogether. Okay, moving on. If you've got a decimal calculation, so 4.5 times 1.2, which came up earlier today, you can round each of these numbers to the nearest integer. 4.5 becomes 5, and 0.9 becomes 1. This means that the result of multiplying them together should be approximately 5. Now, if you get 54, then you've gone wrong. It is typical for students to place these two numbers in columns and keep decimals in line. The reason why this is a common mistake is because when we add and subtract, we always keep decimals in line. However, when multiplying, keeping decimals in line will almost always result in an incorrect answer. Students should be encouraged to take a few seconds to form a basic estimate, which ensures that their answer is along the right lines. Next, we've got a fraction question. So you've got 3/4 of 52. Well, straight away you should know half is 26 and a quarter is 13, and that totals to 39. Now, think about it this way. If you know where a half is, you can, and you know what the whole is, so 52, then you know that your answer is going to be somewhere between 52 and 26. Fractions can be quite confusing for primary school students, but a basic sense check should tell you if you're way off. It can help to employ a more visual method to understand and calculate fractions. For instance, drawing out a whole, which represents the 52, and then dividing it into small parts, with the halfway point at 26, helps a student understand. Next, we've got an area question. So if you were to sketch out a rectangle, and we've got these dimensions, 9.8 times 3.2 centimeters. Well, if you do 10 times 3, then that's 30 centimeters. So you know that if you get something like 300 centimeters squared, then a zero has crept in. Next, on to some secondary school examples. So these estimation skills are also critical in secondary school, and when dealing with more advanced concepts, although I think less so, as there's a lot more abstract thinking and problem solving required. Nevertheless, here are a few examples of questions where you can apply some basic common sense to check your results. The following question involves finding the circumference of a circle. A quick check that anyone can do is find the perimeter of the rectangle mentally, which is 8 plus 8 plus 10 plus 10, which is 36. We know that the rectangle is inside the circle, so the area of the circle must be a little larger than 36 centimeters, but not much larger. To find the actual circumference of the circle, we simply need to use Pythagoras to find the diameter of the circle and then multiply this length by pi. Next, we have a trigonometry question. So when we've got a trigonometry question dealing with right-angled triangles, if the resultant side length of the angle does not fit in with reality, then it is something that you need to go back over and recalculate. In this question, you have to find the length of the line AB, which is opposite the provided angle BCA. As you have the opposite angle and adjacent side BC, you obviously have to use tan and use simple trigonometry to find AB. I know instantly that the provided side length, 28 centimeters, will be a little less than the line AB, because the angle of elevation, BCA, is bigger than the angle of elevation, BAC. I know this even before I begin to calculate my answer to the question. It's a common sense check. Estimation is the 1-second habit that prevents most avoidable errors. Pause before you calculate and check carefully. If any check fails, rethink the method, then calculate. Build this into every question, from money totals to trigonometry. 1 second now saves marks later.
Quick, estimate how long this video is going to be.
11 minutes.
Okay. Let us know if it was right.
Like and subscribe.
Like and subscribe. And they catch nonsense. So for instance, I'll do it again. No, no.
Jesus.
Is it fine if it goes everywhere?